Without further ado, I'd like to introduce John. He is with Corelight, and he's going to talk about some open source tools. So if you've ever done any kind of network forensics or incident response, you're probably familiar with some of these tools, and they're very powerful. So John's going to give us a rundown of some case studies and some real life examples where they've been used and very beneficial in detection.
Thank you. Excellent. All right. Well, thank you for joining me in a post-afternoon, post-lunch slot. I will try to keep this lively, and I will hold Q&A for the end. But I truly am excited to talk about this because I get to spread a great kind of series of knowledge about open source tools, which I take it you're here because you're interested in open source, you've used open source, you're interested in network side, forensics, or incident response. And there's just a lot of great kind of tools out there that we're going to talk about today. We're going to go in depth on 2 of them. We're going to talk about a couple others at a higher level. But today's talk is really meant to be an introductory talk. My background is in security, where I spent my whole career, but never on the operator side. I've done product management and product marketing. I've had the opportunity to go all around the world and meet customers over the last 10, 12 years and sit with their SOCs. I've worked alongside some of the world's best security analysts at some of my past roles and current roles. So I've really learned from the best, and I'm excited to share with you some of the things I've learned from them, because I've literally watched how some of these tools can change people's workflows and outcomes in security teams for the better. And I've seen the joy that can come when someone kind of realizes this and tries one of these tools and sees, oh, wow, I can see XYZ that I couldn't see before, or I can tell my boss with confidence that this is not happening now with this kind of visibility or this kind of alert. And it's great to be able to play a small part in helping spread the knowledge and word about these tools and processes. So as I mentioned, I'm at Corelight, network detection and response company. We've got a booth out there. As she mentioned, we've got some great t-shirts. So if you haven't stopped by to grab one, please stop by. And I've worked across a variety of different solutions. I've worked in the EDR space, endpoint detection and response. I've worked in the identity verification space. I've worked in the privacy technology and security services space. I've got pretty good breadth of solution space knowledge from my career, but I'm always learning. And I'm learning from you as well here at this conference, which is great. And I've already had some great conversations at the booth and would love to talk to some of you as well after this talk. So to give you a quick agenda, we're going to talk at a high level to kind of frame this discussion about using open source with respect to network forensics and network detection and response, NDR. We're going to look at some of the benefits of using open source tools, because some of you, while you might be individually interested in using open source, might have to convince your colleagues or your boss or your organization to make those investments. And I'm going to hopefully share some good arguments that you can take back to your organizations to make that case at your respective security team or organization. We're gonna talk about a few tools in the first part of this agenda, but we're really gonna dive deeper, a little bit deeper beyond the introduction on 2 in particular: open source Zeek and open source Suricata. Sometimes I've heard them referred to as peanut butter and jelly. They go well together, so you'll see why I kind of am focusing on them for this talk. And they're fantastic tools for network forensics and network-based incident response as well. We'll talk a little bit about Corelight today, not too much. I'm really here to talk about open source use cases and integrations and such, but I will touch on Corelight because we have a role to play in this space, and our commercial product actually uses open source technology, which is part of the reason I'm giving this talk, and then we'll hold for Q&A at the end. I want to talk a little bit about the case for network first, because I've already had some conversations today with some people, and I've asked them the question, what sources of telemetry are you using to make sense of what's happening in your environment today? And I've heard today, and I hear frequently when I talk to customers, a common response, which is, oh, we've got host logs, and we've got CrowdStrike installed, and we've got, vulnerability databases and all this great stuff. And then what I don't hear a lot of often is a strong network side coverage. From a forensics and incident response perspective. They'll say, oh, we've got firewall logs, or yeah, we collect NetFlow. And I want to make the case at the beginning of this talk that you shouldn't let network side telemetry and visibility and detection response capabilities take a backseat or be a second-class citizen to endpoint. Just as you want to invest and have really deep and comprehensive endpoint detection and response capabilities, so too, I would argue you should push to make sure that you have the same equivalent capabilities and visibility on the network side. And the reasons for this are as follows, right? The network is a really fantastic place for breadth of visibility, right? So if you're an incident responder and you're looking at a particular alert and you're trying to understand, you validated it, let's say, and you're trying to understand what's the scope of that alert across all, potential affected hosts, let's say, in your organization, you could go to your EDR agent, right, and ask that question. But that EDR agent is only going to tell you about endpoints where that agent is installed. What about all the BYO? What about all of the infrastructure that EDR agents don't go on, whether that's server infrastructure or IoT infrastructure? What about the cloud, right? If this is going to affect cloud infrastructure, right? So there's a whole series of attack surfaces and general breadth across your organization that if you have an EDR agent there, that's great. But if you have the ability to get broad visibility at a single source of truth from your network, you can answer questions like that very quickly. So it's great from a breadth perspective. It's a great starting point. If you're a threat hunter, it's also a great place to start your threat hunting hypotheses and trying to validate if certain activity is out there and then drill down into the depth of endpoint. And I think the other key reason that you shouldn't, discount, NDR and really try to achieve the same level of capability you have on endpoints as you should have on the network is about resiliency, right? When you're dealing with sophisticated actors, nation state actors, and you've got great EDR technology installed, that's a great line of defense. But what happens if there's a zero-day exploit that they're leveraging that fundamentally compromises that system at a kernel level, right? The agent, the EDR agent that's sitting on top of that kind of base level is susceptible to whatever gets exploited at that level, right? And so if you're dealing with a sophisticated adversary and they're able to compromise the endpoint itself, the EDR agent becomes an unreliable narrator. But there's a phrase that gets thrown about in the security world, and a variation of it is the network can't lie. And it's the idea that if you're positioned well in your organization to capture and make sense of your network traffic and store that somewhere, you have an immutable, you have an unchangeable record of activity, of what actually happened, right? Because the adversary can do a lot of tricky things on the network. They can encrypt their traffic. They can do port and protocol abuse to try to disguise themselves as something that they aren't, right? DNS traffic, for example, often gets routed around firewalls, right? Because it can impact business operations. There's a lot of tricks you can do on the network to try to evade detection and response capability. But at the end of the day, as an attacker, you have to push a packet somewhere, whether that's on-premise or the cloud. And if you position yourself in your organization to be there to capture and transform that connection activity, that is an immutable source of truth, right? The attacker can't go back in time and retroactively change that piece of network telemetry that you've captured. So I make that because as you go back to your organization and you're interested in bringing perhaps some of the open source tools we're about to talk about into your organization, you might have to make the case for investing more in the network. Because again, I think a lot of the focus these days is on the endpoint, but it's a better together, it's a defense in depth story. And there's a lot of great examples in the last 12 months even of where organizations that have both of these were very well positioned. If you single thread yourself on either, you're putting yourself in a bit of a precarious situation. So what are the components, therefore, if you're looking to achieve that same level of detection and response capability on the network as you would on the endpoint? And specifically, let's look at this question through the lens of open source technology. You're going to want a detection capability, of course, some sort of analytical capability that can scale, that can find known bad, suspected bad, potentially risky activity on your network. You're going to want evidence to be able to validate those opinions, those detections that are being generated, a source of objective truth, hopefully, that's usable and storable over long periods of time, because you may need to go back in time, days, weeks, months, in some cases. And at some level, if you're really going deep forensically, you might actually want the entirety of the communication over the network, the packet level detail, right? You're going to need a place to consume and store this information. Most typically, that's probably going to be in some sort of SIM environment. On the packet side, capturing packets is just the first step. Then you need to analyze them. So you need an environment where you can actually conduct the packet analysis. And if you're getting more advanced and mature in your organization, you probably want some automation capability on top of the system on the network side as well. SOAR, for example. So the question is, what open source tools can we leverage here to build this stack? What I'm going to show you are simply examples, tools that I've talked to customers around the world. They love them, and they love often using them together, but they're not the only tools out there. I'll put up a screen with some more resources as well. And there's others out there as well. So this isn't an exhaustive kind of inventory of all the tooling out there, but it's some of the more popular tools out there that I've seen customers use. Detection. You could use Suricata. Suricata is an intrusion detection system, also can be configured as an intrusion prevention system, so it can sit inline and actually block traffic. Most people that I see globally deploying this tool are deploying it passively as an IDS. Fantastic, broad, comprehensive detection capabilities against known threats. A signature-driven tool, which we'll talk more about in a few slides. You can also use open source threat intelligence feeds, right? MISP is a great resource for that. There are many in this particular intelligence feed area of open source repositories that you can use to supplement potentially proprietary feeds that you might be paying for from another vendor, or even home curated intel, right, within your organization. Evidence. Zeek, open source Zeek network security monitor, formerly called Bro in decades past, since renamed Zeek, a fantastic generator of evidence about what's actually happening on your network. Archime, formerly called Moloch, a great packet capture and analyzer tool in the open source community. Elastic, a fantastic open source SIM, right? I think many of you that I've talked to today already are either using Elastic or have used Elastic in your past roles. A really powerful kind of set of open source log query, dashboarding capabilities, analytical capabilities. There's machine learning toolkits as well there. A fantastic open source SIM option. SOAR, if you get to that level of maturity in your network stack, right? The Hive, there's a few other great tools out there you'll see on the next screen, but this is just an example, right? This isn't a definitive architecture stack of open source. This is just how I've seen customers that I've talked to architect their environment. Out of curiosity, has anyone in the room used any of these tools? Yes, we've got one hand, two hands, three, four. Okay, a smattering of people have used some of these tools. If I remove Elastic from that question and I ask, have you used any of the other tools other than Elastic on this tool? How many hands go up? One, two, okay, about half. Okay, so we've got some folks that have some Elastic experience. As I mentioned, I've had those conversations. I'm going to guess familiarity possibly with Suricata. So we're going to talk a little bit more in depth about Zeek and Suricata in the next couple slides. But let's also just talk about kind of framing, right? Open source is great because it's free, but it's also free like a puppy. It does require some work. And you may have to sell that work to your peers or your boss if you're trying to bring these open source tools in. So what can you expect, right? What's the work? What's the materials you might need to stand up these open source tools in your environment? Well, typically, if it's going to require hardware, such as with Suricata, open source Suricata deployment, you're going to need your own hardware to run that package on top of. You're going to have to spend some time tuning and debugging it in your own environment, right? If you've seen one network, you've seen one network. It's amazing how networks, corporate networks are like fingerprints, right? There's just so much unique about your network environment that differentiates you from a different organization. And you're going to find that out when you deploy network side tools. And consequently, there may be some work there you'll need to do. If you're in a very large organization with high throughput network traffic, you may also be challenged with some packet loss as well and having to troubleshoot that. On the intelligence detection analytics side of open source, you're going to have to be picking your kind of rule set or detection input into those engines, maintaining that integration, and maintaining the maintenance of those rule sets, right? A new version gets released, you may need to update. A new set of rules gets released that may cause conflicts or generate false positives. That will be on your organization to troubleshoot. In a small lab, you can stand many of these tools up immediately, a matter of hours, a single day of playing around, you'll be up and running with these tools. If you're looking at larger scale enterprise deployments and you're looking at one or more of these tools in a more complex networked environment, you're probably talking about weeks, sometimes months. At the high end, I've seen Fortune 100 organizations take over a year to really get these tools implemented and architected and scaled. So recognize that there's a bit of a journey ahead, and to prepare for that journey and recognize that if you're asking to bring these tools in, you're also implicitly asking for the time to bring these tools into your environment. And just the general kind of system maintenance and monitoring, right? Each of these tools that we just showed on the previous screen have development communities. They're releasing versions, much like commercial vendors release new versions of their product. And it will be your responsibility to kind of maintain and monitor those tools as they update, grow, as integrations get added, as new operating systems, supports are added, et cetera, et cetera. So, I don't say this to scare you off of open source, but I say this to help you prepare to have that conversation with your peers in your organization. If you're interested in bringing these tools in, it's not just, can we use this open source technology? Will legal allow us to use this in environment? It's, can we get the people, whether that's myself and part of my time, and or get a team involved to stand up these tools? So recognize that you're going to be possibly needing to bring in more champions to get those tools rolled out in your organization. Some great use cases. So I think, from an IR perspective, right, some of the tools that we just flashed on screen are really great from an IR perspective. So for example, Suricata, configured as an intrusion detection system. There are many rules sets out there that you can use for Suricata that are open source. One such rule set is called emerging threats. It's maintained by Proofpoint. They have a premium version, and then they have an open source free version. So let's say you've installed, deployed open source Suricata in your environment. You're using the emerging threats rule set, which contains tens of thousands of IDS-based rules that are potentially now firing, and a particular alert now fires, right? But now you need to investigate that alert and validate that it is in fact a true positive. Well, if you've also installed open source Zeek, and let's say you're consuming this information in Elastic, for example, that's actually a pretty straightforward proposition. In fact, and we'll talk more about this, Suricata and Zeek can talk together via community hashing standard called community ID, which allows you to pivot from that Suricata alert in Elastic and say, okay, Suricata tells me that this is a HTTP, post-body threat. Great, now I'm trying to validate that. Show me the evidence, show me the Zeek logs about the network that might indicate more information about the HTTP session so I can help validate this. In the world of Suricata and Zeek, while those are two separate, distinct open source tools and communities, those tools can actually talk well together via community ID, which is a common hashing of the 5-tuple. So it's basically a common identifier for network flows. And you can pivot in your Elastic instance via that community ID from that alert and say, okay, great. Now I'd like to see the logs associated with that connection, that Suricata alert. Now you can validate quickly. What's the converse of this if you don't have this? Well, maybe you have a firewall alert that fires, and maybe you have firewall logs to go with that firewall alert. Maybe those firewall logs are sufficient to help you validate that particular alert, but maybe they're not. And now maybe you need to go spelunking around in your environment trying to find the source of network evidence outside of your firewall logs that might help you validate that firewall alert. Maybe you're bugging the IT team to give you access to some net flow coming out of routers in that particular satellite office, for example. But in an open source world, if you've deployed these tools, you have a central source of truth now in your Elastic instance, where you're getting both signal analytic from Suricata, you're getting evidence to independently validate that that alert is correct from Zeek, and you're getting it in a single source environment, Elastic, that you control. You don't have to go to the IT team in that case. It's great for threat hunting, custom detections as well. So, one great thing about IR is it's an iterative process, right? You learn something by going through the incident response process that you can bring back to either improve existing detection engineering or create net new detection engineering. You can say, hey, I validated that this alert is correct. But in the process of validating it, I actually came across these additional IOCs over here. And I wanted to make you aware of that. Can we build a detection capability against those IOCs? And your detection engineering team might say, great, absolutely. Because we've invested in open source, the beauty of open source is it's open to development. These tools, whether that's Suricata or Zeek, allow the detection engineering team to create new rules and new detections very easily in the case of Suricata. Zeek's a little more complicated, but Suricata, that's kind of a signature that you would write and deploy in your environment. And now, as an analyst, you've brought back new IOCs to your team. They've written a new Suricata signature, and now it's running in your environment, and you have net new analytic technology. And lastly, I'll call out on the far right there, a great use case for open source is about the speed of response when something goes down that is a P1 at your organization, right? Those headline breaking, headline making security events that make all of the security community lose sleep for a couple of days or weeks on some cases. It's really nice to have open source behind you when those kind of events go down, because if you don't, you're typically going back to your commercial vendor and or looking internally, trying to come up with custom detection engineering internally, or you're going to your commercial vendor and saying, hey, can you guys detect this? And if not, how soon can we have a detection in place for this new 0 day that just dropped? But when you have the winds of open source at your back, in many cases, those detections are released within hours, literally hours of this news cycle breaking. And so, imagine yourself 2 quarters from now having deployed Suricata IDS, for example, and some, crazy new 0 day exploit in some critical piece of infrastructure breaks on a Sunday night at 5 p.m., right? There goes your week. If you've got Suricata IDS alert technology installed open source community is most likely going to have some sort of signatures looking for specific IOCs related to that exploit within a matter of hours. We see it time and time and time again when these sorts of things happen. It's not an anomaly, it's sort of the rule. Because you've got hundreds and thousands of people around the globe at all different time zones who use this tool and have writing capabilities around this tool. And so the news breaks in Europe and it's super early East Coast time, but a European member of the open source Suricata community took a couple hours to write a couple signatures, validate them, and release them to the community. And you can go back to your boss on Monday and say, let's run these, segregate the alerts per second so we can figure out if they're valid. But we've got some detection capability that Monday morning when everybody's scrambling, right? So these are just some of the many use cases, I think, that open source makes very easy and is really a great reason to bring open source into your organization. These slides will be made available afterwards, but I've included the links to most of these projects up here on screen. I also included links to our threat hunting guide there. It's a great free resource. It's 35 pages of very kind of technical, but accessible kind of guidance on how to go about threat hunting for specific kinds of activity in your organization, completely free and available on our website. And we also have some freely available rules in the SOC Prime threat detection marketplace. I think it's about 75 different Sigma rules, which if you're not familiar with Sigma is a kind of signature, cross-platform signature kind of language that allows you to create analytics to be used across a variety of different tools. So benefits, right? The choice here is between kind of proprietary closed systems and open source, but it's not quite a binary, right? You might have some commercial tooling over here and some open source over here. You might have all commercial in the data center and some open source in your satellite office. It's rarely, I rarely see all open source deployments. It's usually a combination of commercial and open source, but there's a trade-off you're making in investing in these tools, which is kind of who owns the destiny of the data format and the detection strategy, right? The benefit of open source is you have a lot more control over all of those things, right? You decide you want to swap out your SIM next quarter. You're going to start a SIM replacement project. You set the foundation on open source a couple of quarters ago. You have a lot more control now because there's going to be a lot more SIM technologies out there that can ingest those data formats you've chosen because they're open source. On the closed side, that's going to largely be in the hands of your vendor, right? They're going to own the data and the format. Any new detections are probably going to come from the vendor's detection engineering team, which is great in some cases because that's what you're paying them for, right? But it can be challenging in some cases when you need more control and more immediacy in response capabilities. So it's not that one is necessarily good or bad. It's just there are trade-offs, right? There are benefits to going with closed systems, right? That's less overhead for you to manage from an open source perspective. There's a lot of taking care of the puppy on the right side of this graph. But just recognize that that is kind of when you're choosing tooling and you're thinking about architecture and stack building, this is kind of the trade-off in each of those investments. And again, it's not always an either or situation. Open source can easily, and in many cases does, coexist with commercial technology in your environment. But when I think about making the case, right, and that's what I wanted to equip you with in part in this talk, making the case to your peers and to your organization about, okay, open source seems cool, but it sounds like a lot of work, right? I could just cut a check for this vendor and we can check that box and we can keep moving. Convince me, right, of open source. I think these are some pretty good arguments here for the benefits of open source from a evidence and detection capabilities perspective. You're going to be maximizing your exportability on the evidence side, as I mentioned, right? That SIM replacement project comes along next quarter. It's a lot easier to do that if you're using open source alerts and evidence standards, because they're open source. Most of the commercial SIM vendors have an interest in supporting them and do, as opposed to a proprietary solution where their data format doesn't quite map to the data schema of the SIM that you're now transitioning to, and that's going to cause some pain in the rollout, for example. Extensibility, too, is a big one, right? The ability to be able to modify the data itself is really powerful. And it's a pretty advanced use case, but it's a great target to try to get to at an organization. One customer I've talked to who really has taken this to the nth degree has enriched their network evidence to such a high degree that there is rarely emails or the ticketing system that they're using with their IT team is directly embedded into their evidence set. And what do I mean by that? I mean, they'll open up the ticket and say, there's a vulnerability that's unpatched. We know that because we're seeing signatures here on the network that shows that these systems are unpatched. The IT team says, okay, we'll close it. They close the ticket. They've updated the systems and patched it. And the analytic on their back end automatically reopens that ticket because it sees and recognizes vulnerable systems again in the wild, and automatically reaches out to those people. And if it's not the right part of the IT organization, that customer has actually embedded the contact information, the phone number and email address for those various pieces of server infrastructure in the log itself. It's those kind of like virtuous cycles that you can drive when you can actually control your evidence standards. Very, not impossible, but it's tough to do in many cases with vendor, proprietary solutions. On the detection side, I think we talked about some of these benefits. Choice is certainly one benefit. Transparency is another one we didn't really talk too much about. A lot of vendors pride themselves on their machine learning prowess and analytic prowess in that space. Machine learning is great, but a lot of detection capability we see in the vendor side in the market can be pretty opaque, which means that if there is a problem, if it is a false positive, it's very hard for you as an end user to debug it and fix it, right? That's typically a support ticket filed with the vendor. In the open source world, much of the open source detection technology that you saw there is very transparent. You can actually look at and see a Suricata signature and understand pretty quickly what the logic is behind that detection firing. The same thing on the Zeek scripting side, if you're using Zeek scripting to do behavioral detections. So there's a lot more transparency there as well. And just the ability, as we mentioned earlier, to detect with a community behind you is generally going to allow you and your organization to respond much more quickly to fast-breaking threat news, right? Because you've got a whole community. It's not just your team. It's not just the vendors that you've invested in. It's a global community of open source folks behind the scenes that are all working together to write great analytic technology to detect whatever comes next. On the exportability front, I'll just flash a bunch of logos here on the screen. The point is not to focus on any one of these logos. The point is to illustrate what I mean by choice, right? All of the vendors you see here on screen have support for these open source kind of network detection and evidence standards that we've talked about. You have a lot of commercial choice when you use open source technology in your environment. A quick story I like to tell. So, you can make these arguments, to your peers, to your boss, to build the case for open source. But a great story that I like to tell is the SolarWinds attack, which is coming up now in a year and a half old, but it's a great story because it really hammers home these points that I was making. So SolarWinds, right, is a company that makes network performance monitoring infrastructure, among other things. They had a product, Orion, which was vulnerable. The nation state, allegedly Russia, had basically compromised the code signing certificates. So they were pushing malicious code directly into the commercial product, which was installed at all of the most sensitive networks in all of the world's major organizations. So it was a really, really, really bad exploit and attack surface when it came to light. And the interesting thing about it is we had one customer who who said they were an MSSP, so managed security service provider. So they managed a bunch of other SOCs kind of operations for other customers. Within about 5 hours of this news breaking, they had comprehensively documented whether there had been intrusions related to this attack across all of their customer bases across the last, I think it was 5 or 6 months, documented the evidence, shown where the intrusion had occurred, if it had occurred, what the scope was, sketched out a remediation path. They'd done that within about 5 hours of this news breaking and the IOCs being released. And then another customer we were talking to who came to us after SolarWinds happened, who was using a pretty proprietary network side security solution, said, oh boy, we lost a lot of sleep, as did everyone that first week after that news broke. And we were kind of just waiting for our detection vendor to write capability set to detect these exploits. Not only that, but we were also struggling to figure out, did we even use the Orion SolarWinds product in any of our global infrastructure, right? That basic inventory question that as a security team is critical, like what assets do we have before we can even determine if they're vulnerable? That customer was struggling with their proprietary solution to even answer that question. With open source tools that we saw previously, especially Zeek, you can actually answer that immediate asset question very easily. You just hop in Elastic if you're using Elastic and say, here's the characteristics of SolarWinds Orion traffic, and it'll immediately populate the logs associated with the Orion installations in your environment. It's a couple minutes of querying gets you the answers globally to that fundamental question that the other customer was struggling to answer in those first few days and waiting on their vendor to create detections to be able to actually answer the question, were we hit? Open source community, came to the rescue and came to the rescue quickly for that first customer. So to double click on Zeek, Zeek is a network security monitoring tool. It's a lot of things. It sometimes is referred to as an IDS. It's not really an IDS. It can be used as an intrusion detection system, but it's really a network security monitoring tool. It's been around for a while. It's been around over 2 decades now. And it used to be called Bro, open source Bro, so if you've ever heard that. As I understand it, it's a tool that's talked about in a couple of SANS courses as well. Someone came up to me to the booth just before this talk, and was telling me about all the Zeek kind of learnings he had from a SANS course he just took. It's a very powerful network security monitor, and it does 3 things exceptionally well. It takes raw network traffic packets and transforms them into logs, connection-oriented logs, sort of like Spark notes for your network. And so as an analyst, if you have a question about, well, what did this connection do after it initiated this DNS request? Well, there's a DNS log, and then you can pivot from the DNS log over to the HTTP log, which is a separate log, but they're both connected via a connection ID, which Zeek stamps all connections with. It's connection-oriented, which is important because a lot of the sources of network telemetry that you might get today from just your routers, for example, NetFlow, right? NetFlow is sampled. You're getting snapshots in time of network connections, and they're not invested in tracking every connection over time and finding out what those connections did over port and protocol. Zeek is, and it's a phenomenal tool. It's purpose-built for security teams and use cases. It is also really good at extracting and reassembling files for file-based analysis, a second great source of evidence, logs and evidence. And third, it's a programming language under the hood. The reason those first 2 capabilities exist is because of the fundamental programming language of the open source project. And if you really get involved in the open source Zeek community, you can actually write complex behavioral detection analytic capabilities. You can create new sources of evidence, right? Amazon is a big user of the open source Zeek technology for the AWS web security team. They talk about this publicly, by the way. So they use open source Zeek, and they've actually contributed back to the open source community. That last little bullet you see there, monitors and detects, they wrote, I think, 4 or 5 parsers, protocol parsers, net new logs, right? The logs you see here on the left that Zeek generates. Amazon said, well, we developed some new logging capability in-house related to ICS type protocols. We'd like to share that back with the community, and they did. And the community grew stronger for it. So once you get through those kind of first 2 basic capabilities of this open source platform, the world is kind of your oyster, because if you're technical enough to script and build, you can kind of build whatever you want from a logic perspective on top of this platform. And that's where some of the real power comes in. I won't go into depth here. Don't worry about reading the individual fields, but I kind of sketched out this story earlier for you, right? Zeek is a connection-oriented logging framework. So from an evidence perspective on your network, as a security person, you probably want a connection-oriented logging framework because that's how we think about stories in the world of security, right? The IT person doesn't like really care about what happened 6 months ago from an email client perspective because nobody files a help desk ticket 6 months after the event, right? IT deals in typically real-time problems. Security teams deal in both real-time problems, but also historic problems. And consequently, you need the ability to go back in time on your network fluidly and quickly. And that's exactly what this logging framework does. It allows you to reconstruct and tell stories about what happened in your network in a data format that is sized, so you can store it over long periods of time, and interconnected, so it's pre-correlated. So you don't have to sit there and line up timestamps between two different data sets, right? You don't have to sit there with your DNS server log and your NetFlow and say, well, this UTC is not using the same format as this one. I think this is the same, right? Gone. Zeek is timestamping and connection stamping every single connection. So it allows you to reconstruct and tell stories very easily. You can go to zeek.org. It's up on GitHub. I'd encourage you to join the Slack group. It's great. A lot of activity there. There's a mailing list as well. There's monthly calls as well with the community. And if you're interested in an enterprise kind of version of this, you can come talk to us. It's among many things we offer in our platform. Suricata, the other tool I wanted to dive deeper on. I said peanut butter and jelly, Suricata and Zeek. Suricata is a widely deployed, typically IDS, from what we see in customer deployments, intrusion detection system, which means it's passive, it's out of band, it's not inline and blocking like a firewall or an IPS system. It came out from the Snort project, if you've heard of Snort, open source, just like Zeek. Primarily signature driven and kind of the underlying alert and detection logic under the hood. Really active community. I mean, every day there are new Suricata signatures being released and shared globally with the community. So you're always getting updated and refreshed detection capability if you're using Suricata. It's great for known threats, right? That's sort of the nature of signatures. Signatures implies that you have a prior understanding about a threat or a threat actor that you can write a signature, a specific kind of piece of logic against. Fantastic for comprehensive coverage against broad-based threats or known threats. This is just a sample here of a Suricata alert. You can kind of see there's severity ratings, timestamps. You get the signature class. In this case, this is a HTTP post kind of alert firing. This is the alert. It's giving you the basics of what the alert is. And from here, you can pivot into the data set that I was just talking about from Zeek to start validating. Corelight really quickly. I don't want to spend too much time here, and I want to leave time for questions. Oh, I'll go back really quickly. We make sensors, and the images aren't displaying, I guess, PowerPoint formatting issue, but imagine there's some icons above these. We make commercial grade network detection and response sensors that are plug and play. So if you're interested in these open source tools, if you use these open source tools, if you used them in the past and you're interested in a commercial alternative, I would say come talk to us because we actually use these open source technologies under the hood in our commercial platform. Appliances, cloud, pure software-based sensor deployments, it's prepackaged and ready to go. That babysitting the puppy kind of analogy that I mentioned earlier, that's part of the value proposition of our commercial platform is we take care of that for you. We make it very, very fast to get Suricata IDS capabilities, as an example, stood up in your environment, if that's what you're interested in. If you're interested in getting Zeek level log evidence in your environment, again, we make that very fast, and we've baked it into a comprehensive commercial platform that actually does all of that and goes well beyond that in terms of analytical capability we've developed in-house. All right, go forward. Image is also missing from the PowerPoint, but just to sketch out, left side's network of the diagram, right side is downstream, right? So how does Corelight or these open source tools get the actual packets from the network? On premise, that's typically coming off of a traffic mirror, so a span port, an optical tap, a packet broker at a large organization is what I would recommend just from performance and deduplication and load balancing. In the cloud vendors, most of them have provided virtual native tapping capabilities of cloud traffic. And so Corelight or these open source tools can hook in at that point. Downstream, right, Corelight here is generating the alerts and the evidence and the file extraction that I mentioned that comes from that open source Zeek capability. You can stream that flexibly to a SIM of your choice, to a file analysis platform of your choice. We have our own SaaS backend as well called Investigator, where you can actually consume the alerts and the evidence and do tier 1 incident response and also threat hunting. And the use cases and value propositions you can unlock there on the right? Standing up a threat hunting function from the network side, accelerating your incident response, and creating net new detection and response capabilities, whether that's in-house or with the community. Because all of the benefits I mentioned of open source, if you use those tools, you can also get with Corelight too, because those same open source rules you can actually run in our platform because it's a fundamentally open network detection response platform based on those same open source technologies. I mentioned we've also gone beyond the open source, so we've done a lot of custom development work here at Corelight to extend those capabilities that are already quite powerful in the open source. We've done more R&D work in-house to even further extend them in our proprietary version. We've done a lot of work on the encrypted traffic analytics side. So we've got dozens and dozens of insights that our researchers have come up with that gives you insights into things like, hey, even though this SSH connection is encrypted, we know it's a large file transfer, or we know it's a small file transfer, or we know it's a human typing keystrokes over this SSH connection versus a machine talking to a machine. Those sorts of analytics that don't require traffic decryption, you can get with Corelight's commercial product. On the Suricata side, we offer and support Suricata AES in our platform as well. And we haven't just slapped the peanut butter and jelly on a box and sold it to customers. We've done some custom engineering work to make it a lot more performant and easier to manage. And so in our world, the Suricata alert actually gets embedded into the Zeek logging framework, which reduces the amount of pivots as an analyst you would need to do. In the open source world, as I mentioned, you can hop between those two data sets via community ID. It's not hard, it's just an extra hop. We've removed that hop in our product, so it's a direct pivot from alert into log. And we've also done some engineering work on our appliances to make it very highly performant and kind of dynamically share the CPUs across the two tools. In the open source, back to that second slide I showed you, performance bottlenecks, packet loss can be a challenge in open source. So our team did a lot of work to engineer away those problems on our appliances. Oops, I'll go back really quickly. Just some customer quotes here. Really these quotes are also quotes, endorsements of the open source technology as well, because a lot of what they're talking about here, right? The security engineer that says, I like to have this data and I wouldn't sleep well at night if I didn't have it. He was talking about the Zeek-based logs and evidence that Corelight is generating. So in short, I will close out, and I think we're at time. So if there are any questions, feel free to ask. But I hope this gave you a good introductory overview of some of the open source tooling available for kind of network side forensics, incident response, detection engineering, and gave you a little more information specifically about Zeek and Suricata, and gave you some good arguments to take back to your organization if you're looking to bring these tools into your environment as well. And if you're looking for commercial alternatives, you can come talk to us.
We have about 4 minutes until our break. So any questions from the live audience? I do have some questions online posted for you, John.
Sure.
One of the things I just want to mention is don't forget to visit John and the other vendors sitting at their booths, even if you're not interested in their product. You're listening to great practitioners. Maybe you want to get out of your normal day-to-day, like maybe you're sitting in a cubicle with no windows or something, and you want to see what else is out there. These are great people to network with. First question was, how do we best do NDR if most users are work from home and most applications are SaaS or cloud hosted?
Yep. So yeah, the work from home movement from the pandemic has definitely shifted the network kind of workloads and where we see traffic today. And VPNs is a great example of this. A lot of companies have shifted to VPNs. And the question is, well, how can we get visibility? It depends about where you tap your network, right? So how do I get visibility into X network class of traffic is really a question about tapping and architecture. So there are ways you can tap at your data center, right? To get visibility into VPN connections coming into that environment. What was the other part of that question? VPNs and? Yeah, SaaS. Yeah, so a lot of workloads. The other big trend, right? Somewhat accelerated by the pandemic, but also very much independent, is just the cloud adoption and acceleration, right? A lot of workloads that used to be on-premise are now in cloud environments. I flashed it on screen really briefly, but we do have commercially, Corelight has cloud side capabilities. So we can deploy these sensors in AWS, for example, and give you visibility into the workloads and traffic occurring in your AWS environments. So there are abilities to tap in these cloud environments. I think I mentioned, right, these cloud providers, for the most part, are now providing native virtual taps in their cloud environments for you to hook systems like Corelight or like some of these open source tools into to do the same sorts of analysis workloads you would do on premise, but in the cloud. So yeah, those are definitely two trends that have changed the kind of landscape in the last couple of years, especially of network detection and response capabilities. Encryption, which wasn't asked, but I'll just mention, is another one, right? The rate of encryption that you see as a total makeup of network traffic is only going up and to the right. TLS 1.3, the latest TLS standard, is only reducing the observable kind of pre-handshake characteristics of an encrypted traffic connection. That's another trend, right, that we have to confront from a network detection and response perspective. Corelight's kind of approach, as I alluded to, is really around squeezing insight without breaking and inspecting. So we have hundreds, literally hundreds of unique encrypted analytic capabilities. We can identify hundreds of different VPN clients, for example, and tell you this is this VPN client, this is that one. We can tell you things like this is risky SSH, this is risky RDP, for example. So we're doing a lot of work there. Our partners, in another way, right, to approach this problem is simply decrypt, right? I say simply. In reality, decryption is often far from simple, requires budget and people and management and TCO, but it is doable, right? There will be certain parts of your network that you will be legally able to decrypt. You will have the budget to decrypt, and you will be able to invest in the solutions to decrypt. So yeah, those are all three trends that are kind of changing the nature of network detection and response, and we have to confront all of them, right? Dealing with encrypted traffic, dealing with cloud workloads, dealing with work from home, where much of the data center HQ traffic that we used to be defending is now outsourced into endpoints and various third-party services. So a good question, and one that Corelight's keenly focused on, and these open source tools as well. We're starting to see a lot of signature writing and community detection engineering that's focused and looking at cloud environments in particular. So if you're interested in getting involved in some of these communities and you have a cloud side interest or expertise, I would definitely encourage you to check some of these out. There's some really cool work going on out there, because again, these open source tools are used by some of the biggest cloud providers and some of the biggest VPN providers and et cetera, et cetera. So it's their problem too, right? And they're using some of these tools to address this problem as well. We have time for one more question, or we can call it a time if we're at time.
Well, I mean, I have a quick one for you if you want to answer. How confident can you be when using these open source tools?
Confident. It's an interesting question. There's confidence that the tools are working, which requires oversight, right? You can't just set and forget these tools. You have to monitor these tools, right? You have to make sure that packet loss isn't occurring. You have to make sure that the false positive rate coming out of some of the analytical open source tool isn't overwhelming your tier one team. So there is confidence requires ongoing practice of monitoring and verifying that these tools are working as designed. Confidence from does this stuff work? Is it effective? I'd say that gets validated almost weekly that I see. If you're on Twitter in the security community, you're going to see people talking about these tools and talking about how they found XYZ or enabled some great new use case with these tools. So truly, I feel like every week I see validation on the public internet of the validity of these tools. And then the third part of that question is maybe, are these tools themselves possible attack points, right? Like, do I need to be concerned about introducing open source into my organization because it's open source, anybody can contribute. Could someone backdoor me through it, right? A valid concern. And to which I'd say, two things. One, the open source community itself is kind of a self-check on that, right? It's just in the way that a commercial vendor has a valid concern about QAing their code to making sure that there's nothing vulnerable in it. So too does the open source community. And that's an exercise that they do as they release new updates to these tools. So there's not that nobody's watching it. There's a community watching it for sure. And the second thing too is a lot of these tools are passive, which is to say they're out of band on your network, which doesn't eliminate risk from a vulnerability perspective, but certainly reduces it, right? If you have an out of band tool, open source tool on your network that gets compromised, it's out of band, right? They're not going to be able to directly impact your traffic flows. They might mess up the tool that's sitting passively to the side listening, but they're probably not going to be able to directly impact your traffic flows in that instance. Again, doesn't eliminate risk there, but certainly reduces it compared to something like a firewall, for example, right? That's in line making decisions about traffic coming in and out of your organization. If somebody compromises that, that is a very big problem. Still a problem with passive tools, but a reduced attack surface because there's less they can do with those tools. Great question. Okay, I think we're at time then. All right. Well, thank you everybody for the time.